Welcome to a new test and teardown video. This time I'm going to play with a Philips RC Generator PM5110. It's in quite alright shape. Looks like somebody dropped it here, but other than that it's quite nice. I've been testing a little bit around on the switches and see there is a problem with the release. See, that is weird, right? And then the other, so there is something to look at. There isn't really a lot of features, just frequency from 10 Hz to 100 kHz in 4 ranges, and each range is just a little bit over 1 decade. And we got an attenuator, square wave, sine wave, and on off. That's really all there is to it. And there's a little extra switch here on the back. That one is the settling time, so I believe this is the AGC, the automatic gain control. That is, of course, in the amplitude feedback loop. And here you can set, is it fast or is it slow for low distortion? And that is, of course, something we're going to go and play a little bit with. Also, this sticker here tells me this unit is from 1984. Other than that, I could not Google anything at all. I was not able to find manuals, schematics, or anything like that. So that is a really, yeah, that's a pity. I just plugged in mains and it consumes about 1 watt, not even powered on. And when you power it on, the power on indicator is this little triangle. Can you see how the output settles? See, at the low at low frequency. Whoa. Look at that. That is crazy. So when I go faster, see? It also goes faster. Okay, let's try. Are we in the, see, fast? And then we go back again. Yeah, okay, it's a little bit. Yeah, it's definitely different, right? And then we go with the slow settling time. Oh yeah, there's definitely something here. Whoa. So it's definitely something in relation to the output frequency. So okay, times 110 here, that should be 1 kilohertz. Yes, it is. And this looks nice and fine. We also got the square wave. That is also 1 kilohertz. Oh, the frequency is a little bit higher in sine wave. Isn't that funny? I don't know if you can see this, but my BNC cable here goes, of course, also to my little distortion meter here. Maybe we can do that. So we are on calibrate. So this is, I need to adjust for 100% in calibration mode. And then here is the frequency. See, it goes up and down like that, and that is perfectly fine. And then we go to 10%. And look at that. Oh, it is really outstanding good. So I'm not even able to measure distortion with this meter here. And yes, it is. I mean, it is working. I can prove that by going to a square wave. And then it goes like that, right? Calibrate 100. Okay. So yeah, we don't have any distortion. So I was using a little bit of contact 61, and that always does magic to sticky switches. Look at that, how good it works. So that was a little hidden ad for that nice product. Inside the case, it's of course shielded, so it's coated with this electrically conductive shiny shielding. And then we got these contacts here for proper shielding of the entire cabinet. It's a 2-layer board, quite nice layout and all that. It's called lab gear, and then we got this number right there. I can't remember I've seen anything like this on Philips equipment, so that is a little bit special. I don't know if I'm super happy about that track and that screw. What do you think about that? So there was something they didn't think about, right, when they did this design. On the, oh yeah, remember when I powered this up and I saw 1 watt of mains usage, and that is of course because main entry goes straight to the transformer. There is a voltage selection possibility, so you can solder around here and then you can make it 115 or 230 volt. So, but there isn't even a fuse. So maybe the fuse is built into the transformer. That is also seen. First, when I just read what they say here on the front, RC Generator. So I thought that it's a classic phase shifter RC oscillator, but that is of course not the case. As you can see, we only got 2 capacitors per band. So 2 of those, 2 of those, and 2 of those, and so on, right? There's of course also 2 tiny little capacitors I guess, for the super fast somewhere, but I can't really find them right now. But and then we got a lot of op amps, and the potentiometer is a dual stereo potentiometer, and we of course got some alignment trimmers, and we got the little filament bulb here, and that is for level adjustment or level correction. I'm very sure this is a Wien bridge oscillator, and that could also explain its very good harmonic distortion performance, because that is just a very good way to make an oscillator. So that is what it is. I'm very sure about the Wien bridge oscillator because of the two of everything here in this way that it is made. It must be like that. I've been looking at the date code of the different ICs, and all of these, they're from 85. We had one here, 86, right? If I'm not mistaken. So I think this dates this entire unit from 1986. Gotta be like that, right? Of course, they didn't like to have mains voltage going all the way up to the front panel and all the way near the sine wave switch, and yeah, of course, for good isolation, this is a better way, you know, isolation towards mains. But you see, here is the rectifier diode and capacitors and all that, and then You see the AC from the transformer goes to that switch, and then from that switch to the bridge rectifier here. So that means the peak currents that goes through those diodes, they go along these tracks, and is very clear, close to everything else here that is probably not what I would have liked. It could have been shielded somehow, right? Yeah, but it doesn't really seem to affect its performance. It's really, really good performance. Anyway, so yeah, I don't really have any cool schematics or anything like that to show you. So if anybody finds any schematics or yeah, even a manual, I mean anything really, could you post some links to us in the comments? Because I was not successful with my Googling techniques. I found another funny thing that I can show you here. This is, of course, this little, it's a triangle shaped LED that is doing the indication. But see that little, see this little dot right there. And this is, of course, the alignment dot, so you know how to mount the scale. Isn't that cute? It is not all the way, so somebody maybe moved this dial a tiny little bit, but it actually makes it super accurate the way it is right now. I don't have a lot more to add to this video. I think you have already seen it all. So I just want to say thank you very much for watching.
You forgot to say like and subscribe.
Oh yeah, I did. Sorry about that.